Everybody, we're on page 15 and we're going to start with this topic of symmetry. So make sure you have the date up at the top and that you're with me on page 15. So symmetry is basically when a shape becomes exactly like another if you were to flip, slide, or turn it. When things are symmetric. We usually think of line symmetry that way when you fold something, but there are other kinds of symmetry. So what does it mean to carry a shape onto itself? Let's see what this means. Let's say I had this shape. Let's pretend there's only one there. And I was going to carry it onto itself. One way I could do that is if I turned it all the way around. I just carried it, my hands, and I carried it right onto itself again. That's one way. Another way is if I could even translate it right onto itself. So that's what carry a shape onto itself really means. Different types of symmetry. There is line symmetry, which you're probably most familiar with. If you folded a paper in half and cut out a pattern, you'd be able to have it the exact pattern on the other side. I'm sure you've done that at some point. And then there's rotational symmetry. And then there's like a little subset of rotational symmetry. That's point symmetry. We won't talk too much about that because point symmetry is really the same as reflecting through a point at 180 degrees. So we're going to focus mostly on these two, but there are three kinds of symmetry. So if we're going to talk about vertical line symmetry, that just means if I could fold it vertically and make a line down the middle and you folded one side onto the other, they would match up perfectly. So a vertical line fold would match up. That's vertical line symmetry. Obviously the opposite would be true for like the letter B. If you were to fold it up to down or down to up, it would match up. At this point, these would go straight up to there and it would match up perfectly. And then there's some things that have both vertical like this. Try to make it a little bit smaller there. You could fold it along that line and everything would match up perfectly. Or you could fold it along that line and everything would match perfectly. So that's something that has both vertical and horizontal symmetry. There are a lot of other lines. You can go through at other angles as well. That's just what vertical and horizontal look like. So now we talk about a whole bunch of different little figures here, little artworks. We already covered the A, right? We could have got ahead of ourselves there. How many lines of symmetry are there? Here there's really only one. I couldn't cut it this way because this does not match this, right? So I could fold it left to right though, so it has one line symmetry. One line of symmetry. The letter Z is interesting. You gotta look at it to really understand it. If I was to fold this way, this section here would end up going this way, and it doesn't. So it's not going to be able to be folded like that, and the same thing would happen if I went this way. So there are actually no lines of symmetry with the letter Z. The butterfly is sort of like the A, only has one, almost has two, but the bottom is different than the top, so that's just one. There's nothing I can do here. I can't fold this any way I can possibly try it. There's just no foldable lines of symmetry. But this one, they're almost already drawn in there for you. You could fold it this way, you could fold it this way, you could turn it and fold it this way, you could fold it this way, and you could even fold it this way. So this 6-petaled symmetrical flower, you could fold it along 6 different lines. This one here, I could fold it this way, if this is a square, right? I can fold it that way, corner to corner, corner to corner. So a perfect square, right, if that was a square, would have 4 lines of symmetry. This is very much like this and this. there's no way to really fold this, because if I folded it down the middle, this chunk would end up like this, and that's not where it needs to go, right? And this chunk would end up like that. That's not what it ends up like. So there are really no lines of symmetry on a parallelogram. At first you might think this one has some, but it almost looks like a fan blade, and it's not going to be symmetrical. So there is nothing there that would line up if you tried to fold it. I mean, fold your paper, hold it up to the light, try it. It won't work. This one here, I see one line of symmetry. Now I'm going to have you do the remainder. How many lines of symmetry with 33? How many lines of symmetry on number 34? We already covered the letter B, but how many lines of symmetry? Looks like we have a rectangle here. Let's really make it a rectangle. That bothers me. How many lines of symmetry with the rectangle? How many lines of symmetry with an equilateral triangle? How about the heart? How many lines of symmetry on a perfect heart? And this cool looking green design here, how many lines of symmetry? You have to look really closely on that one. So there's a lot of writing and a lot of information here. We're going to talk about rotational symmetry, the angle of rotation, and the order. But I'm going to teach it rather than read this. You can always go back, and this will make more sense after I show you down here. So if I have rotational symmetry, that's no longer folding. We're not folding this along a line. Instead, we're turning it. Rotational symmetry. So let's see if I can recreate this. The best I could do, right? And if I was to rotate this, it would match back up. I could rotate it again, and it matches back up. I carried it onto itself, if you remember from the beginning. So this has rotational symmetry. The order of rotational symmetry is how many times, how many positions can you get it to match up before you go all the way around, like in one full circle. So let's just say, just so we can remember we started there. That's the top, right? Just for our own sake. I can go one position, two positions, three positions, and four. There are 4 places where that works. So the order is 4 for that one. That's what order is. Same thing on the next one here. If I had this H inside of a circle, right? You could put your tracing paper over this, trace it, and do the same thing I'm doing. This looks the same here, and it looks the same here. But that's it. If I go all the way back around, I'm back to where I started. So the order for that is 2. Again, if I called this the top, that would help you know that that's another second position, but then I already counted the other one at the top, so the order is 2. Then we have this triple arrow. So you could trace this with patty paper or just watch me. Essentially, we have 3 circular arrows inside of a circle. So let's say that was the top. I could go 1, 2, and 3. So the order is 3. Then you have this horses are allowed sign. Usually you see signs like this that are crossed off, but I'm going to trace the horse, put a circle around it just to get an idea of what they were doing. This is the top. Where else does this look the same? Nope. Nope. Nothing yet. I had to come all the way back around. There was only one position. The order is 1 on that. One position where that looked the same. So the order is 1. What do you think about the bottom 4? What's the order of this? What's the order of this? What's the order of this? How many positions does it look the same before you come up back to the top? And what's the order of this? Now we'll explain what the angle means, because you already know order. If I took this shape, and I'm going to try to recreate it. It's hard to see there, and I called that the top. There are 1, 2, 3 places where that looks the same. So we know that from the last examples. The order is 3. How do you find the angle? You just take 360 degrees and you divide it by the order, whatever the order is. So it turns out that the angle is 120 degrees. That's how you find the angle of rotation. 360 divided by whatever the order is. I'll do a couple more examples here. You have a big red S. An S is a unique letter, sort of like a Z, sort of like a parallelogram. If this was the top, you can even turn your entire packet, rotate your packet around. Nope. Oh, there it is. There's another one. I got 2. Right? I got that place and I got that place. And I already counted that one. So the order on that one is 2, which means if I divide 360 by the order, I have an angle of 180. It took me 180 degrees to get back to where another version of how it looks the same. Okay. I'm just going to do this one, and then the rest are on your own. This looks like a parallelogram. One here. 2. I already counted the back one, so again, 2. We already know from the last problem, 2 is 180. Okay, so you're going to finish by taking a picture of this section down here and uploading a picture of 48 through 55. If for whatever reason you don't have a packet yet, this is easy just to draw and take a picture of.